Hey guys, and welcome to my first series in which we'll cover the content of Calculus 1. Let's get started. So one of the first concepts you'll be introduced to when you start learning calculus are limits, and they can be a little counterintuitive to understand, but here's a good way to think about it. So let's say we had a graph over here, and we have just a random curve. We'll call it f of x. And we want to see what the value of the curve is at some point. Let's call this point A. So what a limit allows us to do is to try to get the value of f of x as this gets really close to a, but not quite a. And you might be wondering, like, why is this useful? Couldn't we just plug in f of a and see what we get? And you're right, we could do that. But on other examples, it gets a little harder. So let's look at our example number 1. So let's say we take the graph of 1 over x, which looks a little something like this. So we can see that as x gets bigger and bigger and bigger, this value of 1 over x starts to approach 0. And we can look at that just by plugging in the values as we mentioned before. So let's look at f of 1. We're going to get just 1. F of 2, we're going to get a half. F of 1,000, we're going to get 1 over 1,000. And this just keeps getting smaller and smaller and smaller. And if we keep making the x value bigger, we'll notice that this tends to 0. However, what we want to know here is what will happen as x just keeps getting closer to infinity. So as it just gets bigger and bigger and bigger. Now here, we can't just plug in f of infinity because infinity is not a number. So this is just not allowed. So what we can do instead is do a limiting process. So we'll denote this as the limit as x gets closer and closer to infinity of our function 1 over x. And what this will now allow us to do is plug in infinity, because we're not really using infinity, we're just using a value that's really close to it. So we can say that this is just equal to 1 all over infinity. Now 1 over infinity doesn't really make sense, because infinity is not a number. I mean, 1 over 1 was 1, 1 over 2 was a half, 1 over 1,000 was 1 over 1,000, but what's infinity? Well, we can use the results we got over here. So we know that as x gets bigger, then our y value will get closer and closer to 0. So we know that as x gets so large that it's basically infinite, y will just be 0. So what this tells us is that the limit as x approaches infinity of our graph 1 over x is just equal to 0. Or that our y value at x is really close to infinity is 0. So just to convince you that this works, let's look at a graph that's a little more easy to analyze, x squared, which we all know. And let's try to find the value at some points and then try to take the limit as well. So then the value of x squared at x is equal to 1 is just f of 1, which will just be 1 squared or 1. At x is equal to 2, we have f of 2, which is just 2 squared, which is just 4. So now let's try to look at the exact same thing, but through limits. So for 1, let's take the limit as x gets really close to 1 of x squared. And as we saw in the previous example, this just allows us to plug in 1 over here, which just gives us 1. We can do the exact same thing for x is equal to 2. So the limit as x gets really close to 2 of x squared is basically just equal to 2 squared, which is 4. Now, other than the example I showed you before, this still might seem a little confusing, but I promise you'll see a lot more of its uses in the next video, which explains piecewise functions, and eventually you'll really understand them when we get to derivatives. Thank you guys for watching until the end of the video. The next video will go over piecewise functions, which will give you a better understanding of limits. I hope you enjoyed, and I'll keep seeing you throughout Calculus 1 and my other series.